All right. Hi, everybody. This is Miss Best, and this video is on comparing functions. Comparing functions, you can be given a function using a table, a graph, or a function rule. In this question, as you can see here, we have a table and a graph. These types of questions will ask you to compare two functions. You can compare their slopes, their rate of change, their initial value, their y-intercept, and some questions will ask you when will one function exceed the other function. So we're going to go through some examples, and if you have any questions at the end of this video, then just please post them to Edmodo. After you finish watching this video, please try to work through some of those problems that I gave you on that worksheet, the one that you guys were competing on yesterday. And if you have questions about that, post that to Edmodo. All right, so let's get started. Here we have two functions. We have bacteria A and bacteria B. Bacteria A is given to us using a table, and bacteria B is given to us using a graph. And the question is asking us which statement is a correct comparison of bacteria A and bacteria B. We need to read through all of the answer choices first and then pick the best one, pick the correct one. So A says initial population of bacteria B is more than the initial population of bacteria A. B says the populations of bacteria A and bacteria B will never be equal at the same time. C says the population of bacteria B is greater than the population of bacteria A after 3 hours. And D says the rate of growth of bacteria B is less than the rate of growth of bacteria A. All right, A, since it's talking about initial population, we can answer those. We can see if that statement is correct just by looking at our table and our graph. Luckily, both the table and the graph include time at 0 hours, which means nothing has passed yet. So that is our initial population. So the initial population of bacteria A is 100. The initial population of bacteria B is around 75. So here we see that bacteria A, its initial population is greater than bacteria B's. So A would not be a correct answer choice. All right. B says the populations of bacteria A and bacteria B will never be equal at the same time. Well, on our table and our graph, we don't have a lot of information to see if they will never be equal at the same time. So we need to do some regression in our calculator, look at the tables, and then determine will they ever be equal at the same time. So if you have your calculator at home, you can just go ahead, you can pause the video here and copy down these steps if you need to, or just go back and forth between these steps and the video. You have a set of notes that have all of those same steps in it. They're your correlation coefficient notes when we were talking about R squared and R, determining the line of best fit. So if you have those notes, please refer back to those and they will walk you through the regression steps. If you don't have a calculator at home, you can download one at wabbit.codeplex.com. Here is the website here, okay, Codeplex, and then we're talking about the Wabbit Emu TI Calculator Emulator. Whenever you hit download, it's going to walk you through the steps, and then make sure that you select the calculator that says TI-84 Plus. That's the same calculator that you use in school. Mine, for some reason, does not work. I've tried to get it to work, but it always, it gives me, I got the new look. I got the TI-84 Plus look, but it's still the same functions as the old calculator. Don't ask me, I don't know what happened. All right, so, but you can download it there, or you can go to Desmos. Desmos allows you to put a table in. It allows you to put a function rule in. It also allows you to put an image in, a folder, anything like that, and so that you can see your data graphed on a coordinate plane, and you can tell from there what kind of regression you should do. I'm going to go back to the problem. So I'm going to walk through the steps on my TI-84, and everything's been clear, so I'm starting from the very beginning. All right, so the first thing I need to do is make sure that I turn my diagnostics on, and I press second 0. And then I'm going to select D so that I can go down to diagnostics on. Okay, as soon as I get to diagnostics on, I'm going to hit enter twice. Make sure that it says done right here. That's how you know that diagnostics has been turned on. Now, I'm going to enter in my list. I hit stat, then edit. And if I'm going too fast for you, please just pause the video so that you can catch up with my steps. But I'm just going to keep going at my same pace. Bacteria A, the L1 is going to be my time, and L2 is going to be the number of bacteria. Okay, remember that L1 is always your independent values, okay, your X values, and L2 is always the dependent values, your Y values. All right, so in L1, I'm going to enter in 0, 1, and 2, and in L2, I'm going to enter in 100, 120, and 144. All right, so now I want to look at my data to make sure that I'm doing the right type of regression. So I'm going to hit second, y equals, so that I can turn my plot on, and then hit enter to turn it on, and then hit graph. All right, at first nothing comes up, and that's normal. So you're going to hit zoom, and then 9, so you can get to the stat menu. All right, so this is what my function looks like. It looks kind of linear, but I know that I'm dealing with bacteria, and bacteria normally grows in an exponential manner. So I'm going to go ahead and try exponential regression first and see if I can get a really good line of best fit. All right, so I'm going to try, hit stat again, then go over to calc, and I'm going to select 0 for exponential regression. Now, if you have the TI-84 Plus at home, you'll have a whole menu of things down here that say X list and Y list and store regression equation and calculate. But since mine is an older model, it does not have that. I can do the same things, but it doesn't have that little menu. All right, so I'm going to hit enter so I can get my regression equation. So my regression equation is 100 times 1.2 raised to the x power. Okay, so I'm going to just show you guys that here. Okay, that's my first function, bacteria A, 100 times 1.2 raised to the x power. Now I'm going to go back to my calculator, and I want to store this regression equation onto my graph to see if it fits the data. All right, so I'm going to hit stat again, go to calc, and do exponential regression again, so hit 0, and then I'm going to stop right here. On yours, you go all the way down, you hit enter until you go down to the line that says store regression equation, okay, and then you continue with these steps. You'd hit vars, and then go to y vars, and then select function, and then y1, because that's where we're storing our regression equation, and enter. Okay, and the equation may come up again, that's okay. From here, you're just going to hit graph and watch the line and look how it goes through the points. Okay, so that is a perfect fit. That's a perfect fit of data. The line is going straight through the middle of all those little squares. All right, so now I'm going to just keep that in mind, and I want to do the regression equation for bacteria B. I'm going to hit stat and then edit, and I'm going to keep my X values 0, 1, and 2, and then I'm going to find the Y values on the graph. So on the graph at 0, my Y value is about 75, so I'm going to enter in 75. And then at 1, my Y value is about 100, so I'm going to enter in 100. Okay, at 2, it looks like it's about 135 or 137, but that's not exact enough for me. So I'm just going to leave 2 off. I only need 2 points to do exponential regression. All right, so now I want to look at this data. So I'm going to hit graph. Okay, and this point down here, that's representing my data. This line right here is the first regression equation. I haven't cleared it out because I want to keep it in there so that I can look at my tables side by side later on. All right, so I'm going to hit zoom 9 again so that I can just get a better picture of this data. Every time you do a new equation or plot new data, you need to do zoom 9 again so you can just see that data. All right, so here are my 2 points. This is 0, 75, and this is 1 and 100. Okay, so I'm going to do exponential because again I'm talking about bacteria. I'm going to do exponential again. So stat, go over to calc, do exponential regression. So hit 0 and then hit enter. Now that is my exponential equation for bacteria B, and I'll show you guys that here. 75 times 1.3 raised to the x. Now I want to put that equation on the graph. So I'm going to hit stat again, go over to calc, hit 0 for exponential regression, and now I'm going to put in my function again by hitting vars, yvars, function, but I want to compare both functions at the same time. So I'm going to change this to y2. y1, y2, all that stuff, that's just y equals. It's just, you're just deciding where to put that function in y equals, okay? So I'm going to put this bacteria B function in y2, so I don't have to clear out bacteria A's function. So I'm going to hit enter, and then I'm going to hit graph. And again, that's the first line, that line that's up there at the top. All right, and the second line is coming in a second. All right, so you see how it goes directly through that point. That's a good fit. And then it goes directly through the second point. So perfect fit. All right, so now I'm going to look at my table. So hit second, graph to look at the tables. Now it's key to remember which function is which. So y1 is f of x and y2 is g of x. So I'm going to put y1 and y2 over top of these. So this is y1 and this is y2. All right, so now let's look at answer choice B again. The populations of bacteria A and bacteria B will never be the same, will never be equal at the same time. All right, so I'm looking through here. I see here bacteria A is larger than B. Still A is larger than B. Still A is larger than B. Still at 3, A is larger, I'm sorry. Then here at 3, it changes. A becomes smaller than B. So I know somewhere in between here, between 2 and 3, they had to cross. Okay, and then B became larger than A. So at some point they were equal. So B is not a correct answer choice. Okay. C says the population of bacteria B is greater than the population of bacteria A after 3 hours. Okay, let's look here. So at 3, after 3 hours, I'm sorry. So at 3 hours, bacteria B is 177, bacteria A is 172. So that is correct. Bacteria B is greater than the population of bacteria A after 3 hours. And then let's just look at D. D says the rate of growth of bacteria B is less than the rate of growth of bacteria A. Look at your equations here, your functions. Bacteria B, its rate of change is 1.3. Or rate of growth is 1.3, and then bacteria A's rate of growth is 1.2. So B is greater than A, so D would be incorrect. The correct answer is C. All right, so if you have any questions about that, then please post it to Edmodo. If you have any questions about your worksheet, post that to Edmodo as well. And thanks for watching. Bye-bye.